Shawn Gordon with you once again, and for this Warp solution, we're going to connect WarpStream to ParadeDB, and I'm going to make use of open source pipeline project Bento to get the data from the topics and into ParadeDB. So what is ParadeDB, you might ask? It's an Elasticsearch alternative that's built on Postgres. It's an open source extension that's aimed at improving the native full text search capabilities of Postgres. And it does that by embedding Tantav, which is a Rust-based Lucene alternative, right inside Postgres. This eliminates the need for Elasticsearch in the stack and the overhead associated with that. So if you have streaming data that needs to be searchable with high performance, this is a great solution. So for example, you've got an e-commerce company, it's using WarpStream to write transactions like orders to Postgres. As they come in, they are building an internal dashboard where they can search through recent orders, and full text search is required here for orders by product name. So this company is processing tens of millions of transactions per month, and the queries must have sub-second latency. So the full text search must be in real time as the records get written into Postgres. With that bit of knowledge established, let's show what is involved. First, let's take a look here at my WarpStream cluster that I called ParadeDB. I've created synthetic data using shadow traffic, and I've got these two topics, products and reviews. I'm going to focus on products, and if we take a look inside here, we can see we have 4.1 million records. So that'll make a good test. Now we're going to need credentials, so let's pop in there real quick. I've actually already created my credentials and I've popped my data in, but I'm going to show you how this is done. We just create them. I'll just call this YY. And here you see this export command. You're going to want this because the Bento script is going to rely on those to be in your shell as environment variables. I'm going to go ahead and delete these now because I don't need them. So now we want to download, install, and run ParadeDB. They've got commands already set up. This is all in the documentation for WarpStream, which I'll link to in the description. So we've got our Docker run. I'm using their default values here on the names and passwords. So while that's running, let's go ahead and look at Bento. Okay, I've got my script here. And Bento is really pretty nifty. It's a generic pipeline tool. It's written in Golang. It's just a single executable to install, super simple. So you noticed I said earlier we're going to need those environment variables. So that's where we're going to resolve the username and password. I went ahead and just popped in the seed broker here. For our purposes, we're only looking at products, but we can list all the topics that we want to grab. I've got this debug section here in case I want to drop things into the terminal to test it out. So down below, we've got a switch statement that lets us switch between the topics. And what this will do is it'll connect to Postgres. This is the ParadeDB version using that Postgres driver here. So these are things that you would need to change depending on your data. Let's come down here because I'm going to be using products. So here we've defined the columns. We could get more creative and actually discern those out of the JSON that's coming in, but that would be kind of overly complex for this example. And for every record that comes in, we create the table if it doesn't exist. Otherwise, we just pop the record in. We execute this with a bento-c script name, and this will run and ingest the records. Now, for my example here, I have 4.1 million records as mentioned, and this all ran no problem. So here we see we've got ParadeDB. It's all set to go. Let's go ahead and connect to it with their command. Let's take a look and see what our table looks like. Okay. And there we see it. So the first thing we want to do is create the BM25 index on the 4.1 million records that we wrote in. This will significantly improve the ranking capabilities of native Postgres FTS. So let's go ahead. Let me grab my command here. We'll paste that in. And this will take maybe a minute or so. So I'll pause and come back when this is done. Okay, that took about 1 minute. Now we're going to test it out to make sure the index was created successfully. So this will look for products with a name of bottle, and we'll get 10 rows. And there's 4.1 million records. This is running on my not so powerful laptop. So that worked. So let's try filtering on some other columns here. Let's add price as well. And there we go. We get everything that's got bottle in it. Here's our price. Here's our inventory count. Now let's try a little more sophisticated stuff. This is going to involve the BM25 scoring, which is a major feature for ParadeDB. It's a significant improvement over the ranking capabilities of native Postgres. FTS, which uses TF IDF, a lot of acronyms there, and those don't maintain statistics for word count frequencies. So let's take a look and see. Bing gives our ranking of the words within the system. So in that query, you can see that we can push down filters like price to the FTS query itself. And that means the search speed is significantly faster than if you filtered it post-search with a SQL where clause. So the BM25 scores, they don't consider rows that don't satisfy the predicate. So that makes BM25 scores more accurate since rows outside of the result set don't influence the score. You'll notice that a higher BM25 score was given to results with both bottle and wooden in the name as opposed to just bottle. So that's useful for ranking by relevance. So next, let's try a join to see the scores alongside the original table. Paste that in. So there you've got the results. I'm kind of just bouncing through the list results, so let's get out of that. And let's take a look at our next example. You can create multiple indexes on the same table. This is useful for scenarios where you want to apply multiple tokenization strategies to the same column. So tokenization is the process of splitting text into searchable chunks that can be indexed and searched. The way you split the text is called a tokenization strategy. So for this example, we'll tokenize the name column using an n-grams tokenizer. The n-grams tokenizer splits documents into chunks of size n. So for instance, if tokenizing the word bottle with n-grams of size 3, it would be split into bot, ot, and tol, and TLE. So TTL, then TLE. This is useful for autocomplete. So if the user has only typed part of the word, you can get the results. So let's see what that looks like. Fire that off, and there we go. So that's created the tokens. Now let's see it in action. Oops, I need to make the BM25 index first. So there's our command. That'll take about a minute, just like the last one. Again, this is on my local laptop. There we go. That took about a minute, as predicted. Now, let's see the n-gram tokenizer in action. And there you have it. That's pretty nifty. So the links for everything will be in the description for the video. And you can come to warpstream.com and get your free account and try everything for yourself.